All right, so we've seen a couple main types of reactions in aqueous solutions so far. We've looked at precipitation reactions involving formation of precipitates. We can predict those based on the solubility table. We've looked at acid-base neutralization reactions. We provided a little bit of context to what acids and bases are to begin with. Now we're going to take a look at oxidation reduction reactions, which are actually a broad category of reactions. These actually encompass many other types of reactions. Which we'll see down the road. So they cast a wide net, if you will. So oxidation reduction reactions are also known as redox reactions. And they actually come from the first parts of each name. So red here. So it's, by the way, it's pronounced redox, not redox. But the read part of it comes from reduction, and then the ox obviously is from oxidation. So generally, we can say redox reactions are reactions whereby electrons are transferred from one thing to another thing in that reaction. Now, originally, the term reduction and oxidation were used to refer to different things, and we'll sort of summarize these here in a second. So reduction, oxidation reduction, or redox reactions will always involve the transfer of electrons, but it can also involve other things. So let's list these. And we'll see that there's a very simple relationship between reduction and oxidation. They actually tend to be the opposite processes. All right, so oxidation, as the name suggests, means adding oxygen. Reduction is just the opposite of that. So if oxidation is adding oxygen to something, reduction would mean removing oxygen. Oxidation also involves the loss, or can involve the loss of hydrogen, which means reduction would involve the gain of hydrogen. If something is gaining hydrogen, we say that it's undergoing reduction. If it's losing hydrogen, we say that it is undergoing oxidation. I'm going to change the terms up a little bit. So adding oxygen or the gain of oxygen. So we're consistent with our terms. Then removing something is similar to loss. And then oxidation also involves the loss of electrons, which means reduction would be the gain of electrons. Again, opposite processes. And then this is manifested in what's known as an increase. Oxidation would lead to an increase in something known as an oxidation number. We'll talk about later on, which means a reduction would be a decrease in the oxidation number or something. So hopefully you're seeing the trend here. Reduction and oxidation are opposite processes. First thing. So if you wanted to remember or sort of put this in your memory bank, you really only need to remember one side of this table, but the other side is just the opposite, right? And that's critical because we're going to have to identify these things down the road, whether something is going to oxidation or reduction. What another way that we can interpret this here, the last thing I'll say in the comparison is an increase in oxidation number means that something is becoming more positive. Or if something is undergoing a decrease in oxidation number, we say it becomes more negative. And all of these can be used to identify reduction and oxidation. In some cases, you will see all of them. In some cases, you will just see a couple of them. And in some cases, you only see just one of them. So you just use whatever is most applicable when it comes to this topic. So There's a little mnemonic that you probably have seen before if you've taken any chemistry before. It goes like this. So it goes oxidation is the loss of electrons, and reduction is the gain of electrons. And the mnemonic here is OIL, which is oil, and RIG, which is ring. Okay, another way that this is represented is slightly different, but it means the same thing. Loss of electrons is oxidation. Gain of electrons is reduction. Okay, and the mnemonic here is LEO. So that's Leo. And GER. So Leo, just insert your favorite fierce animal. We'll say Leo the lion. So it was Ger. Okay, so however, whichever, so you can make up your own, doesn't really matter to me. Whether you use oil rig, Leo the lion goes Ger, or you just remember the table that we have here. It's key that we know the differences between them. And the other thing to keep in mind, which is very important, is that reduction and oxidation must happen simultaneously. So what that means is if something is undergoing oxidation, something else has to undergo reduction, because if something is losing oxygen, okay, something else has to take that oxygen. The oxygen doesn't just disappear. Similarly, if something is losing electrons, those electrons have to go somewhere, and that other thing that is gaining them is undergoing reduction. So we can take a look at a very simple example, and we'll introduce some more terms here to illustrate what's going on. So if we have the reaction between zinc and copper ion, copper 2+, these two can react together to form the zinc ion and copper metal. And this is actually something you did in lab, or you would have done in lab, or you will do in lab at some point. This actually does represent an oxidation reduction reaction. And you can actually predict what's going on based on the table that we just came up with. If we compare what's happening to the zinc on both sides of the equation, zinc here is a solid, it becomes zinc 2+. So it's actually becoming more positive. As a result, the zinc is undergoing oxidation. It becomes more positive. And what that means then, because we've identified that, well then the other thing is going to happen to the other substance in this reaction. The only other thing present here is the copper. So if the zinc is undergoing oxidation, that means by default, the copper has to undergo reduction. It has no other choice. So the Cu2+, on this side, it becomes more negative. It goes from a charge of 2+ to a charge of 0 when you have your metal in the elemental state. So it becomes more negative. So as a result, the copper is undergoing reduction. Okay, so they have to happen simultaneously. They go together like milk and cookies, peanut butter and jelly, peas and carrots, whatever your favorite combination is. Oxidation and reduction is the same thing. They have to occur at the same time. So a couple terms we'll throw in here. If the zinc is undergoing oxidation, it is actually reducing the other thing. It's reducing the copper. So we say the zinc then is called the reducing agent, because it reduces the copper to the copper 2+ to copper 0. And because the copper is undergoing reduction, it has to oxidize something in return. So we say that copper then is the oxidizing agent. Okay, so the terms here can be very confusing. To avoid that confusion, you need to slow down and identify, first of all, what is undergoing oxidation, what's undergoing reduction. Whatever is undergoing oxidation is a reducing agent, the agent of reduction, in other words, the thing that is reducing something else. And whatever is undergoing reduction is the oxidizing agent. It's the thing that is oxidizing the other thing that is present in that solution. So the redox reaction, which we just wrote here, by the way, is just a sum of two things. It's the sum of an oxidation half reaction, and it's the sum of a reduction half reaction. And we can actually write these out to see where we get that from. Okay, so if I take a look, and I'm just going to compare two things on both sides of this equation that are similar. So the zinc and the zinc 2 plus. How does it become? How do we go from zinc solid? How does that become zinc 2 plus? Well, in order for a neutral, remember we're assuming a charge here of 0, in order for a neutral compound to become positive, it has to lose electrons. How many electrons to have a charge of 2 plus? It has to lose 2 electrons. So those electrons will be here. Right? So it may seem counterintuitive. It says, the equation says plus 2e, but that just means that those electrons have been lost from the original, right? You add up the charges on the right side, the 2 plus and 2 minus gives you an overall charge of 0 that you have on the left, right? So the zinc here is undergoing, it's losing 2 electrons. The losing electrons would be oxidation. Okay, and what's happening to the copper then? Well, the copper, the Cu 2 plus Aq is becoming Cu metal, copper metal. It goes, how does it go from a charge of +2 to a charge of 0? Well, it has to gain 2 electrons. So this here gains 2 electrons. The gain of electrons is reduction. So this is the reduction half reaction. Okay, so this is a half reaction on top. In this case, it's the oxidation half reaction. The one on the bottom is the reduction half reaction. If I add these together, what I'm doing is I'm adding the things on both sides of, I'm sorry, on either side of the equation. So on the left side of the arrow over here, I end up with zinc solid plus Cu 2 plus Aq plus 2 electrons. Then my arrow, everything on the right side, not everything on the left, everything on the right side of the arrow is this. So I have Zn 2 plus Aq plus my copper 0 solid. Then I have my 2 electrons. Right, I can cancel out my spectator things, which are the electrons in this case. Right, so I end up then with my overall redox reaction, which is the zinc solid plus the Cu2 plus in 2 plus the Q plus Cu. Okay. So we can write out for this overall reaction, we have the half reactions, and just summing them together would give us the overall redox reaction for this particular process.